Assalamualaikum warahmatullah. My name is Muhammad Shafiq from class EC220-6C6B. So, for today practical test from subject ECG564, I need to conduct a traffic study laboratory task for this subject. But due to the limitation of COVID-19 and the lockdown that is going on today, so instead of going to do the experiment physically, I'm going to dive into virtual world, which is inside the game. So inside the game, I'm going to be conducting the traffic study at the specific location in the game and proposing a solution by using the lab test that we have did since the first. So let's dive into the game right now. So here we are in the game. So the guy that you see here, so this character will represent me in the game conducting the study. So in this game, I have selected this location as the study location. Because it is said that there is a lot of traffic noise problem at this location, and in order for me to solve this problem, I have choose to conduct traffic noise study laboratory as the solution for this traffic issue. So before starting the experiment, I will explain the apparatus. So the first apparatus that is needed is safety vest. As me in the game wearing right now, I'm wearing a orange color safety vest. And the second apparatus is the stopwatch. Well, I can use my phone in the game as a stopwatch. And finally, the sound level meter. So in this game, I will be using phone as a prop really for the sound level meter for this whole experiment. Okay, now let's start the experiment. So to start the experiment, firstly switch on the sound level meter and then select the response time, either fast mode or slow mode. And I choose slow mode because it detects average sound level every 1 second rather than fast mode that detects every 125 milliseconds. And then after that, select the frequency weighting, either A mode or C mode. I choose C mode because it stimulates human hearing characteristic and it is much more accurate for this experiment. And after that, select the range, so we can choose either manual or auto range. So I choose the range between 30 decibel to 130 decibel. And then after all of the parameters have been selected, now hold the sound level meter comfortably and make sure to point it directly to the source of the noise, and the sound pressure will be displayed on the meter LCD display. And lastly, in order to capture the maximum noise level reading on the display, so I press the max button and the machine will capture the maximum reading on the display. And then in order to reset, select maximum button again and it will clear the maximum reading. So the sample was taken for 30 minutes of a total duration, and the noise reading was taken for every 30 seconds. Now after the experiment is done, I turn off the sound level meter, take out the battery, and for result table, we need to fill in the data collected from the previous experiment, which is time and the maximum noise reading during the 30-minute period, and we tabulate for each 30 seconds. And then we need to calculate L10 by using this formula, where the maximum and the minimum noise level is obtained from the table above on the noise column. And then we need to plot a noise versus time graph in order to produce noise curve level. And since we already obtained L10 from the calculation, plot the L10 on the x-axis and you can see that which noise is more or less than the L10 plotted. And from this, we can refer to guideline for environment noise limit and control to check either the noise is over the limit range or not at that specific place. So for the next one, for the frequency table, we need to calculate mean noise, frequency percentage, and cumulative frequency percentage. But firstly, we need to categorize the noise according to the range. To get mean noise, add the minimum and maximum range of noise and then divide it by 2. To get frequency, calculate the number of noise in the noise range. To get frequency percentage, divide the frequency with the total frequency and then time with 100. And then, to get cumulative frequency percentage, we need to bring the frequency percentage on the first row into the cumulative frequency percentage on the first row, and then add it with the frequency percentage on the second row, and then repeat the same process on each row until the end of the data. So after this, we need to plot the S-curve, which is basically frequency percentage versus noise. So since we already obtained the L10, plot the L10 onto the S-curve in order to get the cumulative frequency percentage at L10. This is important to analyze whether the noise at the location will contribute to noise pollution or not. Thus, that concludes the video presentation for practical test for ECG564. So, thank you for watching. I hope you enjoy watching this video. I hope you understand what I'm trying to deliver. And then, that concludes this video. Thank you so much. Stay safe. Assalamualaikum. Peace out.